Finishing touches here, the last couple of questions on the Junior Cert Higher Level 2013 short questions section A. On here to number 12. The graphic shows a logo based on a racing car. Figure 1 shows the incomplete logo. Complete the logo by drawing a tangent between the wheels of the car. So this time it's a tangent that crosses between the two circles, an internal tangent. Show all constructions and points of contact. The tangent is in, the radius goes out. There's the rule we remember, so T in or out. Tangent is inside between the two. The radius of one circle needs to go outside the other. So we'll take the radius of the smaller circle, take the exact radius of the smaller circle and add it on to the bigger circle. So in essence we are reducing the small circle to a point and increasing the larger circle by the same amount. So whatever the reduction is in the small guy, we increase the large. I'll need to apply that increase on a line, so I'll just extend through the horizontal line there and take the radius that I've set of the small and add it on to the large. Now unfortunately there it's falling just, well, it's falling perfectly in line with the back of the car. That's just poor luck really. I want to be able to show this a lot clearer than that now, so I'm just going to take a separate projection here to show this, because I don't want to get confused on what that is. I don't want to confuse anyone. So taking the radius of the small, adding it onto the large here. I now have set up a new question. I'll just grab a different compass. The new question I've set up is a reduction down to a point. Here on the left hand side, reduce down to a point, and on the right hand side it's a larger circle. There's my new question. As I said, on the left hand side I've reduced my circle down to a point, and on the right hand side I've increased it up to a larger circle. I need to get a tangent now from the blue point to the blue circle. So a tangent from a point to a circle is the 3-step process. Join the centres, bisect the line, swing a semicircle, and that gets you a point of contact. Join the centre to the point, bisect the orange line, and I'll draw that bisector. Fold the top of this over so it's not falling. I've drawn in the bisector now, here in red. That bisector is going to give me, in green, it's going to give me a portion of a semicircle from the centre point. I'll draw my portion of the semicircle out, and I can draw the full thing if I want, but there is no need. It has achieved everything I need once it hits that blue circle. That is a construction tangent from the blue point onto the blue circle. It's a construction only tangent. It's not part of the finished design or the finished drawing, but it just gets me one step closer. Now I'm going to reduce the drawing or reset the drawing to its original format, taking it back into the original circle and taking the point back out to the original circle. I'll do this using sliding set squares. I'll just get a pink colour here, something different again. I'm going to join this construction POC into the centre, I'm going to use sliding set squares, and I'm going to go the same angle from the blue point down to the bottom. So they are parallel normals. That gets me a POC down here, and it gets me a POC up here. I have 2 points of contact. You join the dots. That's that question done. So that's 12 out of 15 done. On to number 13. And sheet 13 here. First question is circles in contact. I'll just zoom in a little bit to this. And the 3D graphic shows a plate rack also shown in the elevation of the plate rack and elevation of a plate. So take the plate, drop it into position, and it's going to be in contact with those 2 bars on the plate rack. So what we want to do here is this. We want to relax the question a little bit and find some constructions first that will help us here. I'm going to start off by, I'll just set up vertical again on my sliding set squares. So there's a vertical setup. I'm going to draw the plate on the left side here, just standing straight up on the bar, and I'll do the same on the right hand side, standing straight up on the bar. Better put an axis through this guy as well, so that I can accurately take the radius. I'm going to take the radius of the small and large circle here. So the large circle radius is right there. I'm going to add it on to the small circle. So the plate is going to stand up from that small circle for now. I'll just stand it up there and stand it up there. If you wanted to kind of see what this is, what I'm doing here, you know, you could start constructing. That's the plate on the left side, and this is like the plate on the right side here. And now I'm going to just catch them and hinge them in. If it's pivoting about the center point of the circle. I'm going to take the center of this plate on the right, and I'm going to pivot it in. I'll do the same here on the left. I'll take the center and the center of the plate and pivot it in. And where the common position is, that's where the path of the left and right meet. But that has to be the correct center point. To find points of contact here, it says show points of contact. Point of contact between 2 round objects lies on a line joining the centers, and a line joining the centers, giving us this guy here as the POC, and this one here as POC. This is back to my original radius of the actual plate from the center, hitting both points of contact if we're accurate here. And for that final marker too here, set the smaller radius for the inner area on that plate and scribe it in. So the only way that I can think of there to solve this one, or a nice simple way to solve it, add a plate on the left side here, move it, swing it in. Add a plate on the right side, swing it in, get your common position. Very similar to what we'd have done in combined movements for solids in contact. Second last question, auxiliary. We're not given a projection angle. We're given the slope surface, we're told what direction we will be looking at, and we're given the x and y one. Very common question, and we're going to use sliding set squares again. We'll set up the x1, y1 angle, and we'll use that, and we'll slide off here. I'll move both set squares over a little and project everything from the plane. Just take them away for a minute. The heights are going to be established from the elevation. So if you project, just link up the plan and elevation. If you project from a plan, it becomes an elevation. The object doesn't change height, we just change viewing position. There are only 2 heights in this object. There's the height here on this left hand side, and I'll just take it up from here and mark it. and there's the height right up at the very top of the object here. And I'm going to mark that on the same line. The heights are parallel to the ground, so just so that I can reach any other points. I don't want to be using my compass over and over, so I'll just take parallel to the ground across from both. And now it's time to figure out where everything is. So if I start off with this back surface here, this orange surface, it starts on the ground, it goes up to that height there, first height that I've marked. So I might start marking that in. So based on two projections, first projection is there, second projection is here. So that's going to be that orange surface on the left hand side. You don't have to add colour here, by the way, it's just for the video. It might make it a little bit clearer to see. That's the orange surface that stands up along there. I'd like to get surface S here, so that's the orange one I've done now. I'd like to get surface S next. It goes all the way along the ground, right out along to the front point, so that is here. Hard to add much more there, but there it is, and it goes across to the point at the front. I need to find this top point now, so it's going all the way to the front. It's going back up to this top point here. And back down to the orange. So I might just add a little bit of colour onto that as well. There's the blue surface. I'll keep this light now. There could be hidden detail coming in here, and there's definitely more detail to add anyway, so I'll keep it light. That is that blue surface all along there. That is that one on the elevation. Next, I'm going to go with the top area where the knives are actually pressed down into here. So I'd like to do next, which is right this one here, from the orange running along with the blue right up to this top line here. This top line here on the blue, and it stays level all the way across to here. Same height across to here, and it joins back down to the orange. Final step is hidden details, so bringing this back surface into it here, the grey one here at the back, it goes from the top of the green at the back down to the ground here. And that's it, hidden detail and all in. It's not, there's no extra hidden lines across or anything at the back. We have our orange, blue, green and grey surfaces, orange, blue, green, and the grey surface is hidden. Final question on this short questions exam is here, back to our graph based on coordinates. The x and y axis are shown and marked in single unit intervals. Very important point there, so it's all in ones. Complete the graph using the following coordinates. Now, if you want to, of course, you can just number in coordinates or the intervals. It might make it easier and ensure you don't make any mistakes. 1, 2, 3, 4, 5, 6. Just to ensure that there's no simple little mistakes made. So A is minus 1, 1. B is 1, 5. C is 3 along the x and up to 2 along the y. D, 5 along the x and 0 on the y. E is 6 along the x and up to 1 along the y. And F is 8 along the x, 6 on the y. Complete the graph, so I need to just freehand in to join the dots. That's the final question. Unlike a lot of these graph-based ones, when it's or chart-based, when it's pie chart or bar charts, we'll have to add colour. In this case here, there is no colour to add. That is the exam complete.